Then I give the word to Thomas Munzel. The microphone and the screen are yours.
Ladies and gentlemen, first of all, I'm very grateful that you invited me to give a presentation about environmental noise hazards and cardiovascular disease. My name is Tom Munzel. I'm a cardiologist, but also vascular biologist, and I'm from the University Medical Center Mainz. Maybe you know more, the Johannes Gutenberg University. That's why you can read actually books. So that's a very important invention from Gutenberg. And you see here our clinics. Then we have this very beautiful church, which is older than 1,000 years old. And you can see in the night, this is the way to Wiesbaden. Also a very nice city. It's a very nice environment. Let me start with Robert Koch. He said one day man will have to fight the noise as fiercely as cholera and plague. He said this in 910. Yeah. So he got the Nobel Prize for modern bacteriology in 1905. So why can this guy say in 1910 that noise will have such a devastating development? I think just for this sentence, he deserves another Nobel Prize. And we also see that life science is getting more interested in this, let's say, cardiovascular risk factor. We had an article published in Scientist, which beautiful illustrations heard by noise, and it summarizes nicely also our concept. So if you're interested in this publication, I can also send Ulf the PDF file. So it's really nice summary. And what you can see here, how maybe a myocardial infarction occurs. You see here, I would say this is Frankfurt. You have nighttime. You have a nice airplane landing, and you have somebody in the bed having problems with the brain and with the heart. And because the blood pressure increases, the heart rate increases. That's special triggers for plaque rupture. Yeah, so you can see here that atherosclerotic plaques may rupture. Then you get a thrombosis of the coronary artery, and then you get your myocardial infarction or sudden cardiac death. And I will show to you later that this is not just imagination, this may be the real case. That's our team, which is quite strong. And here's Mette Sørensen. She's advising us in our research quite a lot. Then we have here Martin Rösli. He's the world expert from Switzerland. And Matthias Basner, he's actually from Germany, but he's working in the US, in Pittsburgh. And he's also one of our brilliant noise network. Now, let me start with the WHO and the European Environment Agency. So the WHO states that at least 1.6 million healthy life years are lost every year from traffic-related noise in the western part of Europe. 113 million Europeans in 1,000 cities are exposed to noise levels in excess of 55 decibels. So that's very important because usually we say above 55 decibels mean noise levels during the 24 hours. This is causing cardiovascular disease. The EEA states that there will be 900,000 cases of hypertension, 40,000 hospital admissions, 6.5 million suffer from high sleep disturbance. Also very important because we believe that too short sleep, less than 6 hours, disrupted sleep is a very important cardiovascular risk factor, and more than 22 million people suffer from chronic high annoyance. So the people get angry when they hear the noise. And this is also, there are some new developments actually indicating that if you develop annoyance, that you are more endangered than other people having, let's say, more resilience. So we started with a review in 2014 in the European Heart Journal, and Wolfgang Babisch summarized nicely that time in a very simple cartoon how noise may cause cardiovascular disease. So just focus on the so-called indirect pathway. So when we have decibel levels of about 55 to 60, this causes a disturbance of the speech, the communication, the sleep, and other activities. And we get cognitive and emotional responses, this so-called annoyance. And this, of course, reflects stress. And stress is characterized by increased levels of cortisol and also an activation of the autonomic nervous system. And if you have this chronically, that's very interesting. Then you generate your own cardiovascular risk factors. So blood pressure goes up, blood lipids go up. you see blood glucose levels go up, maybe due to cortisone. Blood clotting factors are getting activated. And if this persists for years, you get cardiovascular disease like hypertension, ischemic heart disease, stroke, but also arrhythmia and heart failure. And the question was always, how is this situation translated into cardiovascular disease? How does stress cause vascular dysfunction? So this is one of our major tasks in our laboratory. So I told you that the noise annoyance is a very important new factor. And so the question is, when we just look at transportation noise, what is most annoying? And this is now known for many, many years, that aircraft noise, you see decibel levels and the degree of annoyance. Aircraft noise is most annoying, followed by road noise and by railway noise. And a very important point is that there is a change in the sensitivity to develop annoyance in response to different transportation measures. So, for example, when we look at road traffic noise, you see here part of the hyena study. It was a multi-airport study, so 6 airports were included. You see here the so-called European Union curve. So that's what, let's say, 15 years ago was the normal association between increases in noise levels and the same developing of annoyance. And if you look 15 years later in the hyena study, you see it's almost identical. So with respect to noise annoyance in response to road traffic noise, there is no change at all. But we look at aircraft noise, we see here the European Union curve. There's a huge shift of 7 decibel to the left in the hyena curve, which means the people are much more sensitive to noise annoyance caused by aircraft noise, which is a little bit surprising because the companies were always saying, oh, our aircraft noise are getting more calm and they don't do that the same degree of noise, so they should be better tolerated. But at the same time, we have this huge increase in sensitivity to develop annoyance. So this is a little bit strange. So when we have aircraft noise in cardiovascular disease, I told you these are typical diseases: hypertension, coronary artery disease, heart failure, stroke, and arrhythmia. And the important point is that there are some data from Switzerland, mainly from Martin Rösli's group. He actually showed that transportation noise is associated with myocardial infarction mortality, independent from air pollution. So this is a very important point because we say noise pollution never comes alone. So always when we have noise pollution, we also have air pollution. So when you have car exposure, car noise exposure, you get a lot of pollution. If you have aircraft exposure, you get a lot of confrontation with ultrafine particulate matter. So this was independently associated with myocardial infarction mortality. But we have to consider when we have both stressors available, noise plus air pollution, that we will have maybe additive adverse effect on cardiovascular health. So this is a beautiful study just 1 year ago, 2 years ago, also from Martin Rösli's group from the Swiss Zurich airport. They actually looked for nighttime deaths and actually they realized that exposure to noise levels 2 hours preceding death were significantly associated with mortality for all causes of cardiovascular disease. So what they realized was when an aircraft was landing or starting, then 2 hours later, there was a sudden cardiac death for the highest exposure group, which means more than 50 decibel. And the group with low noise was 20 decibel. So when we compare these 2 groups, we see that always this death occurrence, and this was due to all causes. It was due to ischemic heart disease, myocardial infarction, and heart failure. And the interpretation was when we have in the night an airport event, an aircraft event, that this wakes you up, it increases heart rate and blood pressure, and these are a very important trigger to develop myocardial infarction, ischemia, or arrhythmia. And this is something we should consider, and it reflects to some extend the figure we have seen in the scientists. So in Mainz, we have a large prospective cohort trial, the Gutenberg health study, which included 15,500 participants. So it's much larger than the Framingham study in Boston. And what we have seen that increasing annoyance in the study participants is related to more incidence of atrial fibrillation. That's very important because atrial fibrillation, of course, is an important trigger for stroke. So this explains, at least in part, why the sympathetic drive makes fibrillation at the end more cardiovascular stroke. And which is also getting more and more evident is that noise and annoyance is associated with depression and anxiety disorders. So when you look at the right side, here's depression, here generalized anxiety, that when you have slight annoyance compared to extreme annoyance, so the likelihood to develop depression in response to extreme noise is at least doubled. And this explains why, for example, the antidepressant medication in the Rhine-Main area is strongly increasing. Now, coming to this neurobiological mechanism I talked to you, how important is the limbic system, which is actually important for the regulation of fear and anxiety. And a part of the limbic system are the amygdala. And you can measure the amygdala activity by doing PET-CT scan. And this group in Harvard, actually, they compared people exposed to high noise and to low noise. And you see when you are exposed to high noise, you see the amygdala lightening. But if you go down to the aortic root, you see the aorta ascendens, that there is evidence for inflammation. And the group also has seen that those who have amygdala activation and vascular inflammation, that at the end have more MACE, major adverse cardiovascular events. So here you see again the correlation between noise and amygdala activity. The louder, the more activation of amygdala is seen. You see that those who are having noise below 55 have less cardiovascular events compared to those above 55. So that's actually the level I told you from the WHO, which actually postulates that noise levels above 55 decibel are more prone to develop cardiovascular disease. So this fits into that concept. And the concept is, again, that we have noise, we get amygdala activation, sympathetic nervous system activation, systemic inflammation, atherosclerosis, and then major adverse cardiovascular events. And an interesting follow-up paper from the same group showed when you have resilience, you are protected. Yeah, so you have less cardiovascular death, less myocardial infarction, heart failure, and coronary and peripheral revascularization. And the resilience degree was actually found out by filling out questionnaires. So my special task was, how about pathophysiology? What is the reason why the vessels are getting damaged by noise? And we started in 2011 and published our first paper in 2013 in the European Heart Journal by Frank Schmidt. And what we actually did, we exposed healthy medical students to noise. So we used an MP3 player. And importantly, this was an investigation done in the house of the study participants. So it's not the laboratory story, it's a field study, what this noise research called, because it's in the house of the people. So we had 30 noise events and 60 noise events. We also used polygraphic screening devices, which is something from the sleep researchers. So the combination of both is very attractive. And we did measuring of endothelial function flow mediated dilation, which has prognostic meanings. So when you have a deterioration of your endothelial function, you are more in danger to get cardiovascular disease. So the peak decibel levels were 60. We had 30 or 60 flights per night. Mean sound pressure level was 43 and 46. And the interesting point was that we've seen you get a dose-dependent decrease in endothelial function and flow-dependent dilation, which was very surprising because we thought these are healthy medical students. There is no way that we see the other day a deterioration of this parameter. Then we gave acutely vitamin C and we could improve endothelial dysfunction, which means when we have noise stress during the night, then the vasculature is forming more oxygen-derived free radicals, which can be catched by vitamin C and at the end improve endothelial dysfunction. It's also important that we randomized the exposure plan. So control 30-60 noise events, control 60-30. And the important point was when we are doing noise exposure to 60 noise events for the very first time, we had a very strong deterioration. Now, the first time we had almost very few reduction of percent dilation. When we did it repeatedly, so when somebody had 60 noise events in the night and he had before 30 noise events, then the deterioration of endothelial function was much worse. So at the end effect, we don't have a tolerance development. So the people don't get used to vascular damage. They get more super sensitive, and we call this the priming of effect of noise. And we have seen that stress hormone levels, the plasma adrenaline levels, went up significantly. We also did railway noise. We have seen the same. We see strong sleep disturbance, endothelial dysfunction, and we see significant vitamin C effects. We also compared healthy subjects and patients with coronary artery disease, and you see when you have coronary artery disease, the deterioration of endothelial function is worse compared to healthy people, which is something what is to be expected. So in response to our publication, John Dienfield, the Pope of endothelial function measurements, he made a very nice editorial. Actually, he had also a very nice title, Nighttime Aircraft Noise Exposure Flying Towards Arterial Disease. And he's, in my mind, completely right. So he postulated that when you have noise, you have stress, you see an increase in stress hormone levels, the blood pressure go up, and you get endothelium damage. Yeah. So the endothelial lineup is producing less nitric oxide, which is important. It's like a nitroglycerin, which dilates the coronary arteries and all the other vessels, lowers the blood pressure. And nitric oxide is getting attacked by superoxide, and then we get this combination peroxynitrate, which has been shown to be the damaging, let's say, combination, which at the end is initiating the atherosclerotic process. And of course, when we have less nitric oxide, we have more contraction and less vasodilation. So based on his editorial, we decided to make a new animal model. And this was summarized in a Nature Review article. I don't want to explain it to you completely, otherwise I need another half an hour. But the important point is that we translated our human data to an animal model. Peak level 85 decibel, mean sound pressure level 72 decibel. We applied noise for 1, 2, and 4 days. And for comparison, we used identical mean sound pressure levels of white noise. So white noise is, for example, when you have a TV and you don't have a channel. So you get then a noise, which is called white noise, which was used as a comparable noise parameter. And I can tell you immediately that white noise had no negative effects at all. So what we've seen when we expose our mice to noise, the blood pressure is getting higher. So this was no surprise. We see an increase in stress hormone levels, noradrenaline, dopamine, Ang2, and adrenaline. And maybe some words again to this endothelial function measurements, because it's very important, because it has prognostic implications. So usually we just have nitric oxide in the endothelial lineup, which is causing a nice vasodilation of the vasculature and lowers the blood pressure. When we have risk factors, that's very important, like diabetes, hypertension, high cholesterol, or smoking, then the endothelium produces more superoxide, and this superoxide is attacking nitric oxide to form peroxynitrite. So the vessels are getting stiffer. For example, if you have more spasm in the coronary arteries, you may also get more myocardial infarction. And we can test this by this blood pressure device. So we measured the diameter of the brachial artery. It's here 4.5 millimeter. Then we make an upper arm occlusion with a blood pressure cuff for 5 minutes. We open the blood pressure cuff, and then we get a reactive hyperemia. And the red blood cells actually, they stimulate the endothelium to release nitric oxide, and you get then a dilation by about 9 to 10%. And the important point is endothelial function of the forearm nicely correlates with endothelial function of the heart. So that's why we can, like guru, predict whether the patient will have more cardiovascular events in the future. So we did that in mice, what we have seen in humans, and actually we could nicely repeat the results. So we see here endothelial function in the mouse aorta. We can dilate the artery NO dependent with acetylcholine, and you see 1 day, 2 and 4 days of noise, make a shift to the right, which means there's endothelial dysfunction. We also measured NO production. You see the NO signal is getting smaller compared to the controls. So we lose NO. And I told you that the superoxide formed during noise stress, it's eating up nitric oxide. And that's why actually hypertension, endothelial dysfunction, myocardial infarction, and heart failure may occur. And that we have oxidative stress is shown in this slide. You see nitrotyrosine. It's a marker for this product NO and superoxide reaction. We get this peroxynitride, and everything which is brown reflects oxidative stress. And we also that endothelin expression. Endothelin is one of the strongest vasoconstrictor in our body. This goes strongly up in the vessels exposed to noise 1, 2, and 4 days. So the important message for me doing now vascular biology for 30 to 40 years, within just 1, 2, or 4 days, we can get the entire pathophysiology of atherosclerosis just exposing these animals to noise. We infuse nothing. We give no cholesterol. We don't make high blood pressure by infusion or something else. It's just the noise which has such devastating effects. And when we look now for this more special cartoon, we can say the aircraft noise stimulates the limbic system to release more catecholamines. Then we get more an increase in cortisone levels and oxidative stress levels. We get endothelial dysfunction, more production of reactive oxygen species, and at the end, more vasoconstriction and more atherosclerosis. I told you that sleep duration is very important. It predicts cardiovascular events and outcomes. So it's important that you sleep longer than 6 hours. If you sleep less, then you get more cardiovascular disease. And it's also important the fragmentation of the sleep. So when your sleep is ongoingly interrupted, you are really in danger of getting myocardial infarction, hypertension, or heart failure. And there are some reports, nighttime noise from the hyena trial in France and in Athens in Greece. And both groups actually established that when you have nighttime noise, that you get a significant increase in blood pressure. And so the next task for our animal experiments was just to test what happens when we expose the mice in the night and what happens when we expose the mice during the day with noise. This was published also in the European Heart Journal. And the interesting point was just when we expose the mice in the night with in the sleep phase with noise, we get endothelial dysfunction. So we get a disturbance of vascular integrity. When we expose it during a wake phase, also during the day, then there's no problem. Endothelin expression just goes up when we expose the mice during the night. And we see that blood pressure is going significantly higher when we expose the mice during the night. And you also see here the systolic blood pressure and diastolic blood pressure. Both are very sensitive to increase stronger when we apply the stress in the night. And this is here summarized that nighttime noise is really the problem. So what we do next is, for example, checking the effects of daytime noise on endothelial function. So far, we just did nighttime noise, and we are very interested to see when we apply daytime noise, whether we see endothelial dysfunction at all. It's also important that we check the brain, and there are some very important enzymes involved being responsible for cognitive function, for memory and learning. And we have seen actually that these enzymes were downregulated due to aircraft noise. And we have also seen essential dysregulation of the internal clock. We see that nighttime noise makes oxidative stress in mouse, and just the nighttime noise increases oxidative stress, not the daytime noise. And now it's getting a little bit complicated. When we look for the superoxide or oxidative stress makers, there are some enzymes, this NADPH oxidase. And we know, for example, that inflammatory cells, the macrophages or the leukocytes, they contain this NADPH oxidase NOx2. And the important point is that when we're doing all this noise investigation, we have seen that the body of the animals was flooded with this macrophages. So we chosen a knockout model where these cells were not present anymore. And then we have seen when we have this NOx2 knockout animals, that at the end, for example, the downregulation of this important brain enzyme downregulation here was completely prevented. So we can say that inflammation in the brain in response to noise causes degenerative effects, which are prevented when we kill these inflammatory cells. And we are pretty convinced that this explains why, for example, in Heathrow Airport, this annoyance study and reading capacity study of school children, where they showed that with increasing noise and noise annoyance, that the reading capacity goes down, that this is at least in part due to important negative or adverse effects on brain functionality. And of course, this very important paper from Mette Sørensen, she just demonstrated a higher incidence of dementia in a national cohort study. They found that transportation noise, railway and road noise is associated with a higher risk of all-cause dementia, dementia subtypes, especially Alzheimer's disease. How can we protect us from noise? We can use noise barriers. They are very effective. They can reduce noise by 20 decibel and they are pretty cheap. We can use brake blocks for trains, building insulation, building design. Electric cars, a little bit disappointing, just reduces the noise by 1 decibel. But nevertheless, it's an important step in the right direction currently. And at the end, I just want to put your attention on the fact that noise is never coming alone. I told you that we have road noise, we have air pollution. When we have aircraft noise, we have also air pollution. And here's a paper published by Joost Lelyveld in European Heart Journal. Here, you can see here the map of excess deaths due to air pollution. This is worldwide. Interestingly, almost 9 million people die because of air pollution. And just imagining that COVID-19 is killing so far 5 million people. Air pollution per year, 8 million people, and nobody's talking about it. Also see that Norway looks pretty good. So the concentrations, it's not very brown like it is in Germany. So Germany has the 8th place with respect to air pollution worldwide. In Europe, 800,000 people died due to ambient air pollution per year. 40% ischemic heart disease, 8% stroke, 32% other non-communicable diseases, which means diabetes and arterial hypertension. And you can see here that Germany is really in a bad position. And I hope we can improve in future. And I'm very promising that our future project will help to identify the mechanism underlying noise and air pollution-induced cardiovascular disease. So currently we believe when we have air pollution and noise together, that this will trigger similar events from the pathophysiological point of view, which at the end have additive or even exponential negative effects on the occurrence of cardiovascular disease. Everybody's associated with endothelial dysfunction, inflammation, and will at the end lead to obesity, hypertension, diabetes, and also atherosclerosis, and at the end cardiometabolic disease. And just to show you that we are prepared, we have a nice exposure chamber where we can put mice in. We can actually here make an inflow for air pollution, for ultrafine particulate matter. And we also have speakers. And this is indeed a worldwide unique prototype where we can construct aircraft noise. So we have a combination of noise and air pollution, and we'll see how the animal behave. And this was my presentation, and I hope you enjoyed it. Thank you very much for your attention.
Thank you, Thomas.